Hi, my name is Rowan Strauss, and this is my science fair project. I did which local creek had the most bacteria in it, and I did this because one day I was walking by the street and I found a dirty creek, and then my mom brought up bacteria, and I'm like, why not just do bacteria in local creeks for my science fair project? I did this because I wanted to learn about bacteria and how it grew and how polluted these waters are. My hypothesis was that Burnt Fork Creek would have the most bacteria in it, but actually it had the least bacteria in it. Tanyard Creek had the most bacteria in it. And my conclusion was that we should take better care of our water and we should do more about trying to stop it. My research was about local creeks and their bacteria, and all about bacteria and some harmful bacteria. In my materials, all you have to do is get 3 creeks, 3 Petri dishes, 3 cotton swabs, and a heating mat to keep it under control. And all you have to do is drive to the creek, take water samples, place Petri dish on heating mat, and then wait for bacteria to grow.
My name is Galia Fisher, and I'm from Dunwoody High School. My project is called the Instant Hit Song, and basically what we did is analyze a bunch of songs, the top hit songs of the year 2009, and we analyzed the notes in the songs, and we checked what the most common notes are, so what the mode notes are, and we have a huge graph of all the songs that we analyzed and all of their notes, and then we lined them up and we figured out what the most popular first note of the song is in the chorus, the second note, the third note, and so on, and until we reached note 44, and that's how we made an instant hit song of our own, which is right here. So we ended up discovering that the most popular key signature is A flat, and that it is possible to create an instant hit song by taking all the most popular notes from all the songs to create a sort of mode note song, even though it might not be as catchy as a song written by actual humans.
My name is Ava Lowe, and I go to Wimbrook Elementary Theme School. My project title was, is slime better with glue or shaving cream? My hypothesis was that slime was better used with glue than with shaving cream. My hypothesis was proved correct. Some of the materials I used were shaving cream, contact lens solution, Elmer's glue, a whipping spoon, a measuring cup, food dye, glitter, another measuring cup, baking soda, and I have this slime 1 with glue and shaving cream, slime 2 with shaving cream, no glue, slime 3 with glue, no shaving cream, and last I have my slime journal.
Hi, I'm Craig Steinhauer. I'm from Henderson Middle School, and my project is on testing the HMS school cafeteria cleaning rags and water for bacteria. I'd always noticed that the rags that we used to clean the tables were just completely filthy and disgusting, and I'd always wondered how much bacteria was really on it. So then my teacher said, oh, you have to do the science fair project. So I was like, okay, I've been thinking about that lately, so I'll put it to the test. So I hypothesized that the number of bacteria on the rags would increase throughout the day. At the beginning of the day, there would be little bacteria, and towards the end of the day, there would be a whole lot more. So I brought in all the equipment I needed. Like, I brought in the Petri dishes and the swabs and all that, and I took the samples, plated them on the Petri dishes, and then took them home to my incubator where I grew up the samples. And after a few days, I looked at the samples and they had grown up, and it showed that my hypothesis was correct, and throughout the day the bacteria on the rags and water had grown. The rag at the beginning of the day had only 6,800 bacteria, but by the end of the day, it had 152,000 bacteria. The big difference. My conclusion is that we could, to take steps to help curb the spread of illness, we could use disinfectants and cleaner water and rags to wash the tables in future.
Hello, my name is Olivia Williams, and my project is Feel the Burn, Where is My Relief? So basically, my project was testing to determine which antacid works the best against relieving heartburn. So I tested 3 different antacids, Tums, Alka-Seltzer, and Pepto-Bismol. So what I did was I created an artificial stomach acid using hydrochloric acid, salt, and water, and then I would test the antacid by dropping it in the Alka-Seltzer. Then I would test the acidity level before and after the test by using pH strips. And my results were that Alka-Seltzer had the best results of relieving heartburn, and Pepto-Bismol had the least results.
I'm Stephen Reed.
I'm Bradley Towner. I'm Jay Johnny.
And so the title of our project was The Effects of Different Liquids on the Growth of Oral Bacteria. And so we all went to a microbiology lab and tested our mouths. We swabbed it, put it in a petri dish for a couple of days, and saw how well the bacteria grew in different environments. And so there was water, Gatorade, lemon juice, ginger ale, and vinegar. And we saw which ones that the bacteria flourished the best in. And that was the water. And so we learned what fluids might we not want to put in our mouth, because then the bacteria will grow more and could lead to like gum disease or something like that.
We each had different results because we each have a different method of cleaning our mouth. Like for example, they're just standard brushing, but I used a tongue scraper, and the tongue scraper seems to have gotten rid of a lot of bacteria that forms in our gums and our tongue, and they can clean our oral hygiene very well. And so that is the reason that our graphs show that I had the least amount of bacteria growing.
Hello, my name is Rachel Dressler.
And my name is Diksha Khanna.
And our project is called Fingerprints Inherited
Or Random.
The goal of this project is to see if fingerprint patterns are inherited from parent to child.
Rachel and I are both very interested in the life sciences, especially heredity and genetics, so we thought that this would be a great project to research.
Our hypothesis was if 2 individuals are related, in our case parent and child, then their fingerprint patterns would be more likely to be similar.
We proved our hypothesis by capturing the fingerprints of related pairs and unrelated pairs, and then we compared them to find the similarities.
The patterns we used to compare were the arc, the loop, and the whorl, and we compared the parent and child to see if they had a similar fingerprint pattern.
So our charts depict our results from our research, and Table 1, as shown here, shows the de-identified information of all our participants, the code we use for all of them so that it would be de-identified, and their relationships within their families.
And to make the code, we separated it into 3 different parts. The first part was each different family gets a different number. The second part would show if the person is either a child, a parent, or a grandparent. And the third part is an abbreviation for the fingerprint pattern they have,
Which is depicted right there.
In conclusion, we proved our hypothesis to be true, that in fact fingerprints are inherited from parent to child.
We definitely recommend other people to try this study since ours was limited by its small sample size.
Thank you for your time.
Hello, my name is Krishna Srivatsa from Chambly Middle School, 8th grade. In this project, I built a microbial field cell and tested if soil bacteria are capable of producing energy. And I further did this project by adding a sugar solution, which could prove that the energy could be stimulated by the sugar solution. So I built the microbial fuel cell, seen here. I attached an LED blink rate, And every day I would take a multimeter and attach it to the hacker board and get a energy output. So I did this every day, and at one stage, after the power output stabilized, I would add water. Then after that, the power output stabilized, I added sugar. After adding sugar, I noticed that the energy went up a lot, which is very significant. So that proved my hypothesis that soil bacteria are capable of producing energy, and the sugar solution can stimulate that energy. So in conclusion, the microbial fuel cell can be used to create energy out of just soil and bacteria, which will decrease our dependence on other non-renewable fuel sources.
Hi, I'm Jacqueline Stevens, one of the K-12 science coordinators for the DeKalb County School District. As we conclude our night, I want to say congratulations to all of our students, our parents, and our teachers, and our colleagues as we celebrate our budding scientists and engineers throughout the school district. So tonight we hosted our Novice Division, where our students came from across the district competing in 4 different categories. The categories were life science, earth science, engineering, and physical science. We had students ranging from grades 3 through 5th grade, and they came in to share about their research projects. Throughout this experience, they had an opportunity, most importantly, to tell us what they've learned. Not so much as about if their hypothesis was correct or not, more so about going through the experience. How does this apply to real-world application? Our students came in with multiple projects ranging from creating websites. There were some building apparatuses. There were some studying plants, which sunscreen lotion will protect against skin cancer. So all of these topics are definitely relevant, not only now, but as they go into post-secondary opportunities. We are so elated that our students are really functioning as scientists and engineers on this level.